How do you know if your web application is healthy? Sure, you can check to be sure your site is running, but is that enough? For instance, maybe your database is responding slowly, or your logging has crashed, or maybe your server is about to run out of hard drive space. How would you know that? Well, the answer, it turns out, is with health checks. Health checks are built into .NET Core web applications. You can use them to verify and report on the health and stability of your application. They can even be used to tell your load balancer to restart your web server. In this video, we're looking at ways to easily implement health checks in our ASP.NET Core projects. Now, if this is the first video you've watched of mine, my name is Tim Corey, and it's my goal to make learning C# easier. One of the ways I do that is by teaching context. There are a lot of tutorials out there that will teach you what to do. I go a few steps beyond that to show you when to do it, why you should or should not do it, what pitfalls to avoid, and what the best practices are. Basically, I get you ready for the real world. If that's the type of training you're interested in, subscribe to my channel and hit the little bell icon to be notified when I release new videos. Finally, in the description, there are links to get the source code for this video, to sign up for my mailing list, to join Patreon, and to get access to my courses. If you're looking to make a career out of C# or want to get better in your C# career, my content can launch you forward faster. Check out all I have to offer at IamTimCorey.com or sign up for my mailing list and hear from me directly. All right, let's go over to Visual Studio and get started. We'll scroll down and say New Project. And we could choose pretty much any type of web project, any of the 5 types for .NET Core. So there's 3 types in ASP.NET Core web application. That would be your Razor pages, MVC, and API. And there's 2 more under Blazor App, Blazor Server and Blazor WebAssembly. Let's start by choosing Blazor Server because typically, if I don't know what type of project to create for web, I just know I need a web project, I'm going to default to Blazor Server. That, I think, is a sweet spot for most projects. So let's call this Blazor Demo, and we'll call this Health Checks Demo for a solution name. Now, I said Blazor Server. We're also going to show this in MVC probably. We could do it in Razor pages, we could do it API. I just want to show off the fact that it's not specific to a specific web project type like Blazor Server. And we also want to have more than one project anyways, so we'll do a different type. Now, we're going to leave it Blazor Server, no authentication, yes, HTTPS, and that's it. Here we go. Now, we do need a couple of NuGet packages. But before we do that, I want to talk about the health of our application. Now, if we just start this application, let's just run this just to make sure it works. And once it starts up, we have to ask a question, is this a fully working application? Is it healthy? And that really depends on your definition of healthy. You see, we can go to the pages, we can click around, we can click the button, see that it works. We can fetch data and see that that works. So we could say, yeah, it's healthy, but is it though? For example, what if our customer reports that the site is slow? Well, slow compared to what? How do we know? Because if we go in later and we go click, 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 seems to work just fine, maybe we're not seeing the same thing they are. Maybe when they fetch data, it's slow, but we're not testing that part. And then how do we determine slow? Is slow visible slow, like 1/1000, 2/1000? Oh, the data popped in. That's slow. But what if it is 200 milliseconds versus 500 milliseconds? What if some of the underlying data this is pulling from isn't available? Those are the kind of things that are a lot more gray area than just, is the site up? We can use a service like, I'm not even sure which service, I haven't used one recently, but a pinging service that kind of pings your site and says, is it up? Well, that's a type of health check where it just says, is it running? But there's a lot more to it than just is it running, because maybe the site is running, but the database isn't. Or like I said, maybe we have logging going on behind the scenes to make sure we log any exceptions, but the log system is down. And if the log system is down, it probably won't crash our application. It shouldn't. So therefore, we're running without catching any of our exceptions. That wouldn't be good, but we can't see that by just going to the site. That's where health checks comes in, and that's the kind of things that we're going to look at in today's video. Now let's start by adding the NuGet packages we need. Let's start with ASP.NET Core.HealthChecks.UI. All right, there's the UI that we need, and we also need the client. So once the UI installs, we'll grab the client as well. Now, if you're a little concerned about downloading NuGet packages, what happened with .NET Core is Microsoft said, instead of having this really big framework that's got everything inside of it, let's make it really small, and then you can just add the pieces back that you need. So don't be afraid to add in NuGet packages, especially since they are, a lot of them are supported by large companies and or Microsoft themselves. So just don't feel like adding NuGet packages is bloating your application. It's just the opposite. We had bloated applications with .NET Framework, and we still needed NuGet packages. Instead, they slimmed it down and said, you bring in the things that you need instead of having them included automatically. Okay, let's go to our startup.cs, and inside of configure services, right in here, we're going to configure our health checks. Let's do this. We're going to do it right here after the add server-side Blazor. The spacing here doesn't really matter, but we're just going to put it in here and say configure health checks just to demark the section. So we're going to say services dot add health checks. Now we're going to add a couple of checks in line right now just to demonstrate how health checks work. So let's start with an add check. And we're going to add just a couple of hard-coded checks to show you how they work, how it interacts with the system, how we can view it, and so on. So add check, we're going to say this is a healthy check, meaning it's going to pass. Healthy checky. How about healthy check? And then in here, we're going to say our arrow. We'll do this, the next line down, and we'll say health check result dot, let's say healthy. And in here, we'll say the check of the foo service worked. Something like that. Okay, so we have one check now. Let's actually indent that. So we have one check. So we said add health checks. That's the overall saying add health checks to our application. And then we have one check that says this, the name of it is just healthy check. That's a generic name that we gave it to say, that this is going to work. Let's actually change that name to foo service. Okay, so we're checking the foo service, which we don't have a foo service. This is obviously just a demo. I'm going to get into more realistic scenarios in just a minute, but I want to start simple. So foo service, and this is an anonymous method that's going to return just healthy. And the response message is the check of foo service worked. That's all it's going to do. Now, that's it for health checks for right now. Let's come down here to endpoints. So use endpoints. And in here, we're going to say endpoints.map health checks. And we'll say /health, which is a pretty standard name. So we're just going to say map health checks to /health, meaning we go to our URL /health, we should get the health check telling us if we're healthy or not. Let's run this. Okay, so I've just added one test health check just to see health checks in action. So /health, and it says, hey, you're healthy. How does it know that? Well, it knows it because this check right here is healthy. What if we change this to a different state? How about unhealthy? Let's change this to did not work. Not that we're showing this yet, but the food service did not work. It's unhealthy. Let's run this. /health. And it says, hey, you're unhealthy. Okay, so it's kind of corresponding one-to-one, right? Well, there's a third state. I just want to show you a state first, then we'll talk about adding more than one check. The third state is degraded. The check of the food service did not work well. So a degraded state is actually I think one of the most fascinating or best states that they could have added. Instead of saying offer on yes or no, worked or didn't work, there's a middle ground here saying, hey, there's a problem, but it's still working. For example, maybe you're doing a database check here and you're saying, hey, can I access the SQL database? And it says, yes, you can, but it took me 3 seconds to get data back. That's not working, but it's slow, which is a degraded state, meaning there's a problem. It's just not stopping work. It's causing a delay in work. And maybe 3 seconds is too long. Maybe you should still say it's unhealthy. But maybe if you expect a 50 millisecond response time and you're getting a 250 millisecond response time, it's still acceptable, but it's not optimal. So you could say degraded. Maybe there's a problem. There's some kind of bottleneck or slowdown, but the application is still working. In that case, between 50 milliseconds and 250 milliseconds, you wouldn't necessarily notice that just by going to the page, because that's still a quarter of a second. So if your app is otherwise responsive, you won't see that. But yet you can see in the background, oh, actually we're in a degraded state because we expect to be at this speed when we're actually at this lower speed. That could indicate an issue. So let's just see degraded state. Again, really cool state. Definitely want to see this in use. So /health, it says, hey, you're in a degraded state. Okay, so far that's just corresponded to whatever we said here with one service. So let's take this semicolon off at the end. I'm going to copy this whole line, these couple lines, and paste in 2 more checks. So now I have the food service, which did not work so well. I have the bar service, which that worked. So let's do Control J and say that was healthy. And this last one was the database. And that also is healthy. So you have 1 degraded and 1 to healthy. What do you think the response is going to be for our health? Say /health, we get degraded. Well, why? Well, because it's going to take the lowest value. So if all 3 of these are healthy, cool. Then it's a healthy system. Everything's working. But if one piece of your application is degraded, your application is degraded. But maybe there's important pieces that are degraded, or maybe there's unimportant pieces that are degraded. For example, if we are doing some work in the background, but maybe we want it to work whenever, just get this work done, but it's whenever, and that's a little slower than normal, we don't really necessarily care, especially if you have high load on our server or whatever else. So that degradation is not a big deal. Whereas not be able to talk to the database fast enough can be a big deal. So how do we split out these values and see these messages? Well, that's where we change this down here to give us a little bit more information. So we can say, comma, new health check options. Notice it wants to extend this whole thing out here. I don't want that. So I'm going to come down here to this next one, which is going to add a using statement for me. So notice at the very top, it's add a using statement right up here for that health checks. Notice I actually have 2 using statements now. Visual Studio is getting very good about adding using statements for you automatically, which is great for when you're typing things out. Not as great when you're doing videos about the code. We often miss those things. So just note, let's go back up there one more time. Make a note of these 2 using statements in case you have to type them by hand. Typically, if you are typing something out and it's not in the using statement, but you get the red squigglies, do Control dot, and we'll bring up an option, and one of those options will be to add missing using statement. Okay, so new health check options, open and close parenthesis, or paren, open and close curly brace, like so, and let's put those on new lines, like so. We're gonna say response writer equals UI response writer. This is gonna add a 3rd using statement. So notice up here now we have using healthchecks.ui.client. That's one of the NuGet packages we added. So response writer dot write health check UI response. What this is going to do is format a JSON response for our health check. So let's run this again to see this new type of response. So /health, and now you notice we have status of degraded. This is a JSON response, but then we have a total duration. That's how long our health checks took. And this is an important part. We're going to talk about it again, but I want to point this out. You don't want your health checks to take so long to run that they degrade your application. So make sure your health checks are quick. So that's just a note there. But then entries. So here are the entries we have in our health checks. The foo service. Well, no data associated. The description says the check of the foo service did not work well. The duration was very, very short. And status was degraded, no tags. We'll talk about tags in a minute. The bar service, that worked, and the status is healthy. The database, the status is healthy. So that's those 3 pieces of information. So instead of just saying degraded, which doesn't give us a lot of information, now we get this whole object of information, this whole JSON object, which we could bring into an application and use in some way, which we're going to do in just a little bit. So let's close this out. And I do want to show you how you can have more than one of these health checks, because maybe you don't want to have all that data. So you say endpoints.map health checks, and say, you know what? I just want a quick health. Just give me the overall quick health of my applications. You can say new options, like so. And in here you can say predicate equals, underscore arrow function or arrow false. So what this does, let's put a semicolon. Okay, so what this does is says the predicate is false. Now what this underscore here is, this is a variable we don't care about. And this is one of those features, I believe it was C#8 that introduced these. Whenever you have a variable that you don't care about, but you want a different variable or you don't want to even worry about it, you just do an underscore. So this is actually calling a method. And this method is going to return back false, just false. So what this will do is it will say, hey, you know what? If the predicate is false, then it's not going to run all the checks. It's just going to run just the overall check. That's it. So it's going to do just the overall check of our application. So let's run this again. We'll do health and quick health. So /health, that's the overall degraded. But now if we say quick health, it says healthy. Cool. So our application is healthy, which it's not, because if we went back to the quick health, it says degraded. So what is health really about? Well, actually, you can use this page to ping to see if our checks are available. It's not running any of our checks. It's just saying, hey, can you get to this spot? It's essentially what you could put here is you could use this page to ping. So an external system could look at this page, which is technically a health check, but what it's going to do is ping us and say, yep, your system is running. That's all this does. It says, yes, the system is running. It's not saying that it ran any of the checks. Any of these checks here didn't run any of them. It just, because remember I said false in that predicate? That predicate false says don't run any of the checks. So therefore, the response is healthy. Now, I mentioned tags. Let's talk about tags. Well, before we do, I do want to talk about this syntax right here because it may be a little confusing. Because this is really shorthand. So what this is saying is create an anonymous method and call it and get back a value. But it's not, it's everything's shortcutted. So let's break this out and show you what it would be if we kind of made this into a full method that's still anonymous. So let's cut this out. And inside these curly braces, let's, like so. Then we'd say return and put our semicolon at the end. That's the equivalent, okay? So we have the curly braces, we're saying return, and this is the value that we're returning. So we could have more lines of code up here, you know, that actually do the real checks. And then after that is when you actually return a value where you say it's degraded or it's healthy or it's unhealthy. So we're just shortcutting all of that and just returning back a hard code result. It's like returning true or returning false or returning one or a string of some kind. We're just getting back the return type it's expecting with one of the three states it's expecting. So this right here is the equivalent of this right here. This right here is just a shortcut to that. Okay, I just want to make sure that was pointed out. I didn't want you to get lost in that. This is what you're going to need to do right here if you want more than one line in your code. Well, now that we have this, I do want, before the close parenthesis or paren, before this close paren, I do want to put a couple of extra values. In fact, one extra value. We're going to say new array. Inside here, we're going to say this is a service, and I think that's it. It's a service. That's the one tag we're going to give it. So this right here indicates our tags. Now, you can have multiple tags if you want. Let's copy this, and after the first paren, we're going to put our tags here. But this one down, this is a service as well, the bar service. But the database, that's not a service. That's a database. And maybe it's also SQL. So now I have tagged these, and we can actually filter based upon these tags. So if we come down here, let's create a new health check that just checks services. Let's start with right after quick health, we're going to say endpoints.map health checks. We'll call this, let's call this health/services. And we'll say new health check options. Inside of here, let's put our semicolon at the end. Inside of here, we're going to say predicate. Remember the predicate? But instead of just saying underscore, we actually want to have a variable name here. And then we have our arrow. And we're going to say reg.tags.contains. Call it service or services. Wouldn't matter because if we said service, it would get services. But if a tag contains service, all right, actually it would matter, sorry. So if we find a tag in the list of tags that says service, we want to include that in our value. We also want to say that the response writer equals UI response writer dot write check UI response. That gives us the full JSON path, or the full JSON amount or text. Let's run this. So it's health/services. So first /health. There we go. We're degraded. /services. But notice that we have only two here. If you can tell this, we're still degraded. We have the foo service and we have the bar service. No database. Now, what if we change, let's not change any text. Let's just change the, this is healthy. So let's change to healthy and we'll change the database to degraded. Okay, I'm not going to change any text. So it's going to, the text is off, but that's okay. I just want to demonstrate what happened. So we go to /health, it says you're degraded. Now the foo service is healthy, the bar service is healthy, but the database is degraded. Well, if we go to /services, it says we're healthy. Why is that? Well, because the foo service is healthy and the bar service is also healthy. And notice it picked up because they were tagged as service. So therefore, it's picking up these two, just these two, and saying, well, the health of this group is healthy, but the health overall is degraded because that database isn't working as efficiently as we want it to. So that's how we can, and let's undo those two. So they're back in order. And we're going to comment this out in just a minute because I want to show next how we can actually create a service that looks at this and puts it into a better format. Because JSON, quite frankly, is not the best format to be reviewing your health checks in. So let's create a new project in our solution. So right click on your solution. We're going to add a new project. And for the type, we're going to create an ASP.NET Core web application. Let's call this Health Checker. And let's create a web application type, which is a Razor Pages project. Now, it doesn't matter which project type I create, but it seems the simplest to create this. So now let's go to Health Checker. And we're going to right click on dependencies and manage NuGet packages. Now, I could find those two packages, but I want to show you a shortcut here. I'm going to close it back out. Single click on Blazor demo or right click and go to properties. Notice this item group here with these two references. Copy the whole thing. These are our NuGet packages. Single click on Health Checker. Paste in that item group. Now, when we save this, if we close it out, we go right click on dependencies, manage NuGet packages, go to installed. We have those two project or packages installed. Really cool stuff. You can manually type out the packages you want, but I still find it easier to find it in NuGet when I'm looking for a new package. But if I'm going from project to project and they both need a certain package that's in both projects, I just copy and paste that, either that one line. So you right click and go to properties. Oops. Right click and say open. Oh, there we go. Edit project file. Sorry. Edit project file. There we go. You can copy just this one line if you want, just this one package. Just make sure it's inside of an item group when you move it over to the other project. We have one more to add. ASP.NET Core.healthchecks.ui.inmemory.storage. There we go. So we're just going to use in-memory storage for this. We're not going to store it in SQL or somewhere else for the long-term health check information. This is kind of going beyond what we need to do in the scope of this demo. I didn't want to go into storing this anywhere else. But in-memory works just fine. And what that'll allow us to do, and you could probably even use this in production. It's up to you how much you want to go back in history and how much you want to use your memory up to store health check information. But what this will allow us to do is use this project, let's close this out, use this health checker project to monitor other projects, other web applications that have health checks. And that may sound a little weird, but it's okay. I'm going to show you how it works. And this is really helpful if you are going to be working with multiple projects inside of your overall structure. Now, when did you ever use multiple projects? Well, if you're a business, you'll probably have multiple sites, multiple web applications, or you might have microservices. You see, you can do this beyond just web applications. We're talking about web applications today, but you could go and implement these health checks in other .NET Core projects, including microservices. Well, if you have microservices, you probably have 10, 20, 30, 50, or 100 plus services. Trying to monitor all those separately and individually would be crazy. Instead, you want to centralize that into one location. We're going to see that with our health checker project. Let's go to startup for health checker. And inside of our configure services, we're going to say services.add health check UI dot add in-memory storage. Now that just added a couple of, I believe it added a couple using statements. It appears not to have. Okay, well, look at that. Didn't even need using statements. But we're gonna add this in-memory storage for our health checker UI or health checks UI. Then we're gonna come down to endpoints and we're gonna say endpoints.map health checks UI. And you know what? That's it. Now, in order to run both of these applications, I'm going to need to right click on solution and say set startup projects. I'm going to choose multiple. I'm going to say the Blazor demo is start and the Blazor or health checker is start without debugging. I'll hit OK. Oh, I have one more thing I need to do. I almost forgot. And that is in health checker, go to appsettings.json. And in here, we're going to add, after this comma here, we're going to add a new section called health checks UI. And make sure you put your comma after the end of the curly brace. So in here, we're going to say health checks. We're going to specify an array of objects. That's why you have the square brackets. And then we have curly brace for an object. We're going to say name. And for this one, we're going to say, well, it's our Blazor server demo. That's this Blazor. Well, let's just call it Blazor demo since we call it that for the project. Blazor demo, and we have the URI, which is the place we locate it at, where the project will start. Well, how do we know what that is? Well, under Properties, Launch Settings, we say it's localhost and the port for SSL is 44380. So I'm going to copy that. And so we're going to say HTTPS localhost : and the port number. And then /health. Now, in a real application, when you are really doing this for real, you would have the URL for your application in production. But you wouldn't have that for testing. You would change this value throughout your build process. So for example, when you're building and pushing to development, this would be the development URL for your site, your development site. And then for staging, it'd be the staging URL for your site. And then this would be the production when you push to production. Locally, we're hosting it on localhost 44380. Therefore, that's the URL, including the /health. That's the health check we created. So notice in startup on our Blazor app or Blazor demo, we have /health, which is that right health check UI response. You got to have that. But it doesn't have any filtering for these tags. It doesn't turn off the predicate. It just says, give me everything. And by the way, write that JSON that's friendly for the health check UI. So this is a health check UI response, which will allow us to consume it in our health checks UI client. So with that, we've got the health checks in place. We got this array of health checks, which we have just one right now. But there's a couple more settings to set up. Evaluation time on seconds is 10. Let's make it 5. So 5 seconds, and every 5 seconds going to evaluate, and then minimum seconds between failure notifications. And we're going to say 60, but that's a default. You can actually change that to be whatever you want for how many times between seeing a failure do you keep reporting that failure. So if a database goes down, how often do you want that reported? Do you want to report it every single time? Well, probably not. You probably want to give it some time before it reports that failure again. So if it fails and then it comes back up, but it fails again within a 1 minute period, it won't report both failures, just the one. So that's up to you how you want to see that. Okay, now we have both of these starting up. Let's run and see if these will both launch. They should. So there's our health checker. This is our Razor Pages application. This is our Blazor page. We go here and say /health. We see it's degraded and why. But if you go to health checker, go /health checks -UI, we get this. And this is really cool. This is a user interface for our, whoops. I know it's got a polling interval of 10 seconds. I think that's because in, not on. Let's try this again. So health checks -UI. There we go, 5 seconds. So this is the default user interface that it gives us. You can actually, make changes, modifications to it, but this is really cool stuff because with just adding those 2 lines, let's see what we had. We had this section in our app.config, and then in our startup we said map health checks UI and add health checks UI and add in-memory storage. Those are the 2 entries besides those 3 NuGet packages and the appsettings.json. The result is this. Even cooler, hit the plus, and we see all of our services, how long they took to run, the description or the message we get back, the status of them, and the tags. We can even go in here and look at the details to see, oh, it's degraded, which doesn't tell us a whole lot right now, but we're going to see how those details update as our services become healthy or unhealthy. This is really cool stuff. It's really simple to do. Notice it says Blazor demo. That's because this is evaluating that Blazor demo project. But we don't have to have just one of these. We can have a whole bunch of them. We can see the overall health. We can expand out and see all these services and databases and everything else, all the checks. Or we can look at it on a per server or per project basis, per web application or per application in general project basis. Let's see how we can implement this. First, let's minimize health checker. And what I'm going to do, let's close out everything. And I'm going to right click on the solution. I'm going to add a new project. Remember I said I'm going to add an MVC project. So let's go to ASP.NET Core Web Application. We're going to say this is the MVC demo. And scroll down here. Scrolls too fast. Web Application Model View Controller. That's an MVC project. No authentication. Yes to HTTPS. Let's run this. And now we can add, let's go to Blazor demo and grab those two packages. Go to MVC demo, paste them in. You could manually go to NuGet and add this and then this, but I find that a whole lot easier to add those NuGet packages that way. Then let's go to startups.cs for our Blazor demo. And let's just copy the health checks we have so far. We're just going to get a quick copy paste because I don't want to go over this all over again for the same exact things. So let's just copy and paste this. There'll be the same names, control dot to add the using statement. There we go. And then we'll also come down here. We'll just add the one endpoint, the /health. Now it's going to yell at us about this. Control dot add the using statement. And control dot add the using statement. So now we have two services that both have health checks. Now they're identical, but they're both in place. In fact, I'm not going to worry about changing anything. We're just going to leave it as is. So we have two demos of this. Let's go to our properties in MVC demo and go to launch settings. Notice it's a different SSL port. Let's grab that. Let's go back to health checker, go to app settings. And what we're going to do is we're going to add, I'm going to paste it up here. I want to copy this whole section. I'm going to put a comma, paste it in there. This is MVC demo, and we're going to grab this port number right here, paste it. There we go. So now we're doing two checks. We're going to check two different systems, the Blazor demo and the MVC demo. And again, right now they're mirrors. I'm going to change that in a minute, but I want to show that this does work. Right-click on solution, say set startup projects. Notice the MVC says none. I want to change it to start without debugging. Let's run all three of these. So we have health check at the end, we have MVC, and we have Blazor. Well, that didn't load well. Seems to have crashed. Let's start again. There's Blazor. But that's it. Let's close this out and start all over again. See if we can't get a better result. There's Blazor. And it's starting behind the other two. That's weird, but okay. It'd be a little finicky trying to start all three. Health checks UI. Look at that. which Blazor server or Blazor demo actually says unhealthy. The target machine actively refused it. Whereas this one is degraded, which is kind of cool. We're actually seeing something different here. But that's an artifact of this not working quite right. Let's see if we can get restarted here. Nope. Okay, let's try it again. Let's coax it back to life here. And if we go to health checks, oops, this is the MVC. There we go. Health checks UI, there we go. It's seeing both of them. We can see, if we can expand out, we can see all the different things that are going on. We can collapse them all to just their project. We can see which ones are healthy or not. Now, seeing checks that don't change isn't really exciting. And it's not really, doesn't seem like it's a valid use of checks. And it's not, because just having a solid check in here that just hard code doesn't do anything. So let's close out everything. Let's minimize the health checker and the MVC demo. And let's dive back into the startup for Blazor demo, because this we're gonna make some modifications to. And to make these modifications, the first thing I'm gonna do is right click on Blazor demo. I'm gonna add a new folder, and let's call this health checks. And we're gonna create a class in here that's going to do a health check for us, one health check. So let's call this our response time health check. What we're going to do is say it's going to implement iHealth check. Notice it's going to add a using statement. So I hit enter, which adds that using statement at the top. But then control dot, I can implement the interface. And let's just give us a little bit extra room here. This is all you have to do to implement a health check of your own. So this is a whole class, but this health check async, what it's going to do is it's going to call this method. Whatever the return here is, which of course right now is throw new not implemented exception, but whatever the return type here is, that's what it's going to check. That's what it's going to do. Now, I need one helper class. I'm going to put the class actually right in here. I don't normally put classes inside of other projects, but this is a really, really simple helper class. It's hard code. It's ugly, but I don't want to waste time implementing it a different way. So let's say public static class. We're going to call this helper, not helper, helper methods, like so. So this is a public static class. We're going to have one property in here. Actually, let's just create a public variable or a public field. So public static random rnd equals new random. Now, what am I doing here? Well, I wanted to have a random value that was accessible and, okay. So this would be accessible throughout my entire application. I could use it. But to do so, I have to make this ugly workaround unless I want to do a lot of work. Let's just do this. Let's cut it out. Let's put it up here. Because we're going to actually make this static anyway. This will make me feel better. This is a more valid way of doing this. The key here for a random number is you don't want to recreate or do the new random over and over again. You want to do new random once for the life of your application. Therefore, we don't want this to be reused or recreated in other places. But since we're doing it just for this health check, we're going to put it outside of the method. And then in here, we'll just do rnd.next. And since this will be a singleton, and I'll show you how to do that in a minute, it will not do equals new random every time. It will do it once for the life of our application. So just want to point that out. Random is a bit tricky to get right. I do have a video on random and how to deal with it, but just know that you don't want to say equals new random inside this method, because then you're redoing that over and over. All right, so let's say int response time in milliseconds equals rnd dot next from 1 to 300. So a whole number between 1 and 300. Actually, it's going to not include 300, so it'll be 1 to 299, but close enough for our uses. I'm going to say if response time in milliseconds is less than 100. That sounds like a good response time. Return task.fromResult, since this is returning a task of this type. This task.fromResult means just return it right away. We're not doing anything async here, but we're returning it like it was async, but it's already done. So task.fromResult, we'll say health check result dot healthy, because that sounds healthy to me. And we'll say string interpolation, so a $sign in front of our string. The response time looks good. And I'll put in parens response time in milliseconds. Like so. Let's unpin this so you can see more of what I'm doing here. I'll kind of shrink it in just a minute. And that's it. So this right here, you can go like this. There we go. So this right here is going to return a healthy result if the response time in milliseconds is less than 100. But what if it's not? Okay. So we'll say else, oops, new line. This is not JavaScript. Else, if it's less than 200, I'm going to say, well, that's actually degraded. And we'll say the response time is a bit slow. It still works, but that's a little slow. And then finally, let's do one more. Actually, let's just copy this right here. We'll say else, and Control J for unhealthy is unacceptable. So if the response time is less than 100 milliseconds, cool, that's healthy. If it's less than 200 milliseconds, that's the else if. That's why we're following through, and we're only doing this if it's not less than 100. So it's 100 to 199. Then say, hey, it's a bit slow. If it's 200 or above, say, no, that's unacceptably slow. That's how you'd build a health check, where you're doing some type of just really quick calculation to say, is this good? Is this not? And then you're telling the system it's either healthy, it's degraded, or it's unhealthy. Notice the return statement's right here. So we're returning that value right away once we evaluate where it is in that cycle. Now, since this is a random number, every time we call the health check async, it's going to get the next random number, which means we're going to see this value change. And that's why I did it. Because I wanted to, since I'm not actually checking a response time, and since if I did, it'd probably be about the same all the time, I am simulating getting a response time. So this code right here, instead of having this, you would do an actual check where you'd actually, ping the server, or you would talk to the database, or you would look for, the service broker, or whatever you're doing in this check. That's what you'd do in this line. So that's our one demo piece here. The rest of this right here would be how you'd actually do the evaluation. Let's implement this in our checks. And in fact, let's comment out all these. Let's comment out all the ones except for the database check. And the reason I want to comment out the database check is because I want to have some type of check besides just, and a healthy one, besides just this new check. So our new check is called response time health check. In fact, let's just copy that. It makes life a little easier. So we're going to say add check, and the type is going to be health time or response time health check. Control dot to add the using for that. And then inside here, we're going to say that this is a network speed test. We're going to say null for the next. This is the health status. So it says the health status that should be reported when the health check reports a failure. If the provided value is null, it reports unhealthy. So what's going to happen is if we can't call the health check, we can't find the health check, whatever, then what do you call that? Is it healthy? Is it degraded? Is it unhealthy? Well, if you can't find a check, that's a pretty significant issue. Therefore, by default, it is unhealthy. You could say, well, it's degraded because we can't find the check. That doesn't mean that service isn't available. You can argue it however you want. You identify what the status should be. But if you put null there, it's going to say unhealthy by default. And then finally, we have here our tags. So we say a new array. We can put our tags here. This is a, let's just say service. Please spell it right. Like so. And that's it. Notice that I'm not putting a semicolon at the end because we're saying dot. We're continuing the line until the last one, and that gets a semicolon. So I just added this new response time health check. But there's one more step to do. And that is to say services.add singleton for that response time health check. And the reason why is because then you declare that response time health check is a singleton. So when it does the add check, it's going to say we're going to get one instance of this and use it for the life of the application, which allows us to keep state between our calls, which is what's going to allow us to have that same random value, that random instance, and we can just say next on it. Now, let's start all this up and see what it looks like. Let's hope that all three will actually launch like they're supposed to. All right, all three seem to be launched. Health checks UI, Blazor demo. This says network speed test is degraded. Wait, it's unhealthy. See, it has changed. It is 203. But now it's healthy because it's 26. So we can watch this status change in real time. We can even go over to the details. And notice it now it has this history where it says, hey, it's currently at 264. It was at 26, but then it was at 203. So this is where the changes in our status come about. And it's a bit slow to 111. And now notice we have more of those checks popping in. Now this list right here, I don't believe it updates until after you close it and open it back up. So if you're polling really, really fast like we are every 5 seconds, which is a bit aggressive, I would tone that down to maybe every 60 seconds or even every 5 minutes. But it depends on how quickly you want to know that your service is unhealthy or even just degraded. If you want to know really quickly, then check every 30 to 60 seconds. Just note that every time you check, it's running those checks over again. So if those checks are long, you want to either make those checks shorter, which you should, or you want to check less often, which if you can, do. So now we can see this change in real time. We can watch our services change. And this is what we can do. We can open this page up and leave it open and just make sure it's all green. And when it's not, You go into the service and figure out why. Oh, the foo service is degraded. Why? Well, it didn't work that well. Well, not a very great message, but you get the point. Whereas you come up here, you see everything's green, cool, but as soon as that changes, we can see the reason why. The response time is unacceptable at 211. I should have put MS at the end of that. I'll do that just for sake of completion here. Makes me feel better. So now I'll say milliseconds. But that's how you use health. That's how you create a real health check. This is a real health check. I encourage you to create a class for each health check. You can even call them from external DLLs. So you could create a package or a NuGet package or something like that. That would be your health checks for your organization. And then you could just bring them in and add them to your dependency injection, like so, and then add them into your checks, like so. I would encourage you to have basically just all these. This right here, quick and dirty stuff, cool, that works. But the reality is that that's not ideal to have all of this in startup.cs. Notice how ugly this section already is, when it really should look a lot more like that. Or even if you had multiple of these, like that. That is clean. That is easy to read. It's easy to understand what's going on. Oh, it's response time health check. That's the network speed test. Oh, it's the database health check. That's for SQL database. Oh, it's the service broker health check for our main service broker. So having that very clean look is important to readability, important to scannability, versus what we have with this. That's why I encourage you to use these checks, among other reasons. Because also notice all of this would all have to go inside of here. So now you can see how fast our startup.cs file goes from 95 lines of code to more like 5,000 lines of code. Not ideal. So we've seen how to add health checks to our application. Really quick to do. We've seen how to add simple health checks like this or like this if you want to do something quick and dirty. And we've seen how to add what I'd call a real health check, which is a full class that does some real work. Maybe it has other methods in here that would do some work and do some evaluation. Again, just make sure they're quick. But we've seen all of that. We've seen how to then come down here and say, hey, just give us something in ping to make sure the service is up. And we can see how to add a filtered health service that just gives us certain tagged items. We've seen how to get the full JSON endpoint for our application. And then we've also seen how to use our health checker project with the health checks UI to get that nice user interface that shows us how all of our different projects are working, how the certain items underneath are functioning, and see all that data in real time. Now, that's how to use health checks. And it's also about why to use health checks, because health checks are, like I said, really important. At the beginning of this talk, we talked about, well, it's more than just a matter of making sure the site is up. It's making sure that, is the database fast enough? We have a slowdown somewhere? Are we running out of memory somewhere? So let's talk about what you would do a health check for. Because there's not built-in health checks. There's not a health check out of the box thing. Now, there are some on the web that people have written for things like SQL Server and SQLite and so on for various checks. But really, the checks are going to be based upon your environment. What are the things you are doing and what are the things that your application depends on? And that's really what we're talking about here, is monitoring our external dependencies for our application in general, mostly. For example, is the database available? That's a big one. And then, is the database responding quickly? Maybe you have a problem with your database getting bogged down. You would figure that out much more quickly if you had a health check in place that had that degraded state when the database was still available but slow. But then we can check if you rely on API. You can check to make sure the API is available and that it's responsive. If you're using logging, which you should be, then you're going to check to see if you have room left in your log file location. Maybe you're logging to files and you don't have it overriding the oldest log file. Therefore, you're just building up more and more log files. Well, you can run out of space on the disk pretty quickly. So you want to check that disk space. Or maybe you just want to make sure that you're actually logging something. Because if the logging system goes down, you want to know about it. Well, you could also check the logging system to see how many exceptions you've had in, say, the past 24 hours. Well, if you expect to have no exceptions, but you have, all of a sudden a blip of 100 exceptions, unless you're looking at the log file all the time, how would you know that? Well, you can have a health check in place that looks at how many exceptions happened in the last 24 hours. And anything under 10 is healthy, anything under 50 is degraded, and anything beyond that is unhealthy. You can figure out what those points are for your application. Maybe you have a system in place where you try to do an action. Let's just say resize an image. And maybe you know that it fails every once in a while because there's not enough memory or whatever. But you have a retry system in place where you retry it 3 times before you totally, error out. Well, you could put this system in a degraded state if you're retrying multiple files more than once. That maybe you're saying, hey, there's a problem here. We're getting it done, but it's really slow because we're retrying over and over. Or maybe you can check the memory of your server and say, hey, I can see that, we're adding a megabyte every hour. And at this rate, the application will have no memory in 2 days. Well, you could alert early as a degraded state and say, there's a problem, we're running out of memory. Or maybe you rely on a queue to get new orders in, and that queue is not available. Your application will still run, but since the queue is not available, it won't be doing anything. Therefore, you can put it in a degraded state, saying, I'm available, but the queue is not, therefore I'm useless. These are just some of the endless amount of health checks you could implement in your application. Implement what works for you. Just like with logging, though, you don't want to implement just to implement. You want to implement health checks that actually you're going to look at, you're going to evaluate, you're going to listen to. Because if you have a health check that puts your application in a degraded state, but you don't care, then why are you putting your application in a degraded state? Just don't. Because why check that and do the extra cycles to check it every 60 seconds or every 5 minutes or whatever? Why do all those checks if you're not going to care if the status changes? So only check things where you care that the status changes. And if you're looking for what to check, look for all your external dependencies, whether it's the system that's running on, whether it's the file system for getting files or writing files, databases, message brokers and queues and external websites and APIs. Check all of your external dependencies if your application relies on them. And finally, actually look at your health checks. Because if you don't look at your health checks, why have them? Leave them alone. Now, the really cool thing is you can use automated systems to look at your health checks. For example, Azure App Services has a preview feature in where if you put your application in a degraded state, it can actually recycle your application, meaning turn it off and turn it back on again if you have a load balance situation where it says, okay, we've got 4 running web applications. They're all load balanced. We've got one of them that went into a degraded state. Let's just use the other 3 for now. We'll restart that 4th one and bring it back up, get it healthy again, and then add it back to the load balancing situation. So that's really cool. You can use an automated system like that. Since it returns JSON, you can do a whole bunch of things with that on your own. You can create your own views or reporting systems or automations. You can tie it into things like, it tweets at you or it puts a message in Slack or whatever you want to do, you have the ability to do. It's just a matter of make sure you actually use your health checks. One thing to note is that you want to be careful how you do these health checks as to what you expose externally. You can say in ASP.NET, you can map and say, okay, that is actually, you have to have authentication in order to see that URL. Now, I didn't use authentication in the system. This is just an intro to, but I do want to point this out because even though it's an intro to, and even though I'm just showing you what it can do, I do want to make sure that you're ready for the real world. In the real world, you might not want to expose your application's health to the external world. This may be an internal only thing. So maybe you don't allow this to go outside the firewall, or maybe you say, hey, you have to be authenticated or authenticated at a certain level in order to go to this endpoint. So just kind of note that there are systems out there or services out there that instead of publishing it on a URL, an endpoint, instead it packages it up and then it will ship that off somewhere, which means it never is exposed on your actual web application. Just note, think that through. When it comes to microservices, you're probably okay because usually your microservices are not exposing things publicly, or if they are, they're only exposing little bits and pieces, not the whole microservice. So you're probably okay there. But if you're got a full web application, think that one through. If you want to be simple about it, just make sure you don't put anything sensitive in that path. And you could even change the URL to be something a little less conspicuous than health. But you can also put authentication against it. Like I said, there's a whole bunch of things you can do. Just think it through. Okay, I think that covers the introduction to health checks. This is a really important feature of ASP.NET Core and .NET Core in general. And it's something that I really would like to see you implement in your applications. I'd like to see you put it into practice. Let me know what you think. Let me know, what do you use health checks for, or what do you want to use health checks for? And let me know if you have any questions down below. I'll do my best to get to them. I've not been able to get to every post or every question, especially detailed questions, just because of the time constraints in doing so for hundreds of thousands of people. But I will do my best to read and respond where possible. But even if not, if you see somebody's question that maybe you could help out on, I'd love it if you would jump in and give them a hand. Thanks for watching. As always, I am Tim Corey.